Okay, so just a very brief review of the MeoMotion class. We have our sprite parts, which hold all the different pieces, our keys, which obviously hold each key, and MeoAnimation, which holds our animation timeline for one of the animations, like a walk or a run. Final temporarily holds information needed to draw it that's used by the MeoPlayer class. Typically, we'd only be accessing the MeoAnimation class from within our game, unless we want to modify certain specific behaviors, and we'd probably do that from within the MeoPlayer class. And this load txt here, as it says right here, you need to place the .txt in your project in the binary, whether it's in debug or release, as we went over just a little while ago. So just put the txt by the executable file, and then you can load it by file name. You can rescale it or use the rescale factor that is calculated. Optionally, this here to adjust the scale of your character relative to resolution. I'll show you a bit more about that later. As I mentioned earlier when I was showing the txt file, there's a PNG or graphics image associated with each character. So if you add a bunch of different characters into one txt export, combining some new ones into the one we started, then if you want to look up the index for an animation and store it, you can provide the expected sheet name. So that would be, for example, hero.png, and then provide the animation name, walk, for example, and optionally you can show error messages if it didn't find it. Sometimes if you're looking up an index for an animation, you may be trying to use the same behavior for AI, for example, and we're actually going to do this, where one type of monster might walk, the other one might run, and so in the regular loop it might look up a walk for all of them. If it doesn't find it, you can, well, if it doesn't find it, it'll return 0, and if it does return 0, you can have it look it up using a different name, like run, for example. So that's how it comes in handy. So you might not want show error messages to be true. You might set it to be false. By default, it's true though. And that way, when you check your output, you can see that there's something wrong in the code where it wasn't able to find an animation. Or you might just have been looking up something that actually isn't in the animation file. If you go into the content folder and you double click on content and bring up the monogame pipeline tool, now you can add the PNG that's associated with your animation. So we'll go edit, add existing item, and in this case I'm going to choose the wizard alien I call Wizzy, a much more simple set of animations, a very simple basic character, and we don't want this txt because that's associated with a rectangle, so we'll just grab the PNG and we'll copy it to the directory, and then we can build. And we'll want to make sure that the txt for that file is actually in the project. So I'll just grab this wizzy.txt out of the export folder, copy it, and then we'll go into our project, go into the binary, desktop x86, because we're doing an x86 release. This isn't the release version, but we'd make a copy in here. So we'll paste this here because that's where our executable is. So the other thing to make a note of is pre-multiply alpha is set to true, which is what we want, and we got it set to true here. So as long as those two match, and the way you're drawing, your blend state for drawing matches, which it will, and as we've seen in MeoMotion, you can animate parts that they fade out. We set the alpha value at 0.02, so when it gets lower than that, it just automatically prunes it from the calculations. So you can adjust that tolerance if you need to. When you set up a MeoPlayer, you can give it a sheet name that associates with it. One MeoPlayer would be the hero, one would be a monster of some kind, and they would each have their own name and PNG associated with them, and that's from the original projects. So when you construct your player, that player becomes associated with that character. So you maybe have a cat player, hero player, or whatever. And then when you set the animations, all you have to do is set the animation as in walk, run, idle, whatever it was named in the original MeoMotion project, and which direction you want them facing, right or left. If you wanted to add extra stuff here to flip them vertically, you could do that too. In which case though, you'd have to go into the update and do the same sort of thing that was done to flip the coordinates horizontally, which was this. So then you flip them vertically too if you needed to do that. I mean, technically you can reverse scale them too. And as I was mentioning before, when we do the duck, when the character ducks down, the user might start or stop pressing the down button partway through the animation, in which case start reverse would reverse that animation back for when he starts standing up. And in the MeoPlayer class, since we already know the sheet name, all we have to do is supply the animation name, and then it will get the index using that information. So let's create a couple of classes, a player class and some monster classes, or a monster class, that will take advantage of this this MeoMotion animation. If you don't want to use MeoMotion animations in your project, I'll show you later how to do animation using a sprite sheet and a sequence of images. So we're actually going to do that after this, and we're going to use that for some of our special effects, as well as a particle effect system. So to begin with, let's right click on platformer and go to add a class. We'll call it player. And for any kind of player class, you're going to have a number of different actions that the player can do. So typically you'd set up your enumerations for those. So they're like little tags for what mode it's in. So there could be none, walk, jump, idle 1, idle 2, duck, spell, and ouch. And we can just keep adding to that as we need them. And for ducking, things get a little complicated, so you usually need a couple of duck states, sometimes more than a couple, depending on how many things you can do when you duck. So we'll just say up and down. And there can be multiple jump states also. We'll have a starting jump where he anticipates his jump when he's in the air, and when he's at the end of his jump, trying to stop. And I usually like to do this, have a left or right facing, and assign them to specific values. So left's -1, right's +1. And also each player would have its own states, like a heads-up display state. We don't have a heads-up display yet, but we'll make a heads-up display class, which will show like life bar and various stats on the character, like experience or whatever. And he'll be facing a direction, starting off with facing right. And you'll have a motion state, which depicts which animation should be running, and it'll start with motion idle. So just kind of taking care of some of the enumeration states here. We also want to remember the last state that he was in. So we'll say last hero motion. We'll say none so that it knows it's initializing from the very beginning of the game. And duck state, we'll just call it duck mode. And duck mode is down to begin with. Same with jump state. And what that means is he's going to be ducking down as soon as they press the button, so he's not down yet. We'll call it jump mode. This should actually be called jump state here. Jump state.start. Here we'll put in some constants, and we'll get back to that. We need access to quad batch. We're also going to have these other categories: map, coordinates, MeoMotion animation, spells. First of all, we'll need access to our map. I'll just use MP so that it's a little quicker to type and a little less to look at. We'll need a reference to the tiles, and we'll also need to refer to the bounce manager, and that's located in the bouncer class under map related stuff. So if a character jumps off of something, the manager takes care of handling all the different bounce events. We'll refer to our input object to simplify input a little bit. And we'll have a rescale factor. So when we load our character for the player in here, we can use the rescale factor that's going to be common to our monsters and to our player. The player will need a position, and that's world coordinates. So I'll just make sure to put world. And you may even want to call it world pose, just to make it a little more clear, especially if you're working with other programmers. And a screen position, where he ends up on the actual screen. And I'm going to use a vector 4 for a bounding box rather than a rectangle. I'll show you why later. We'll always need to keep track of the old position of the character as well as the current world position. So I should put old world here. So world position is where he is in the map, and it's measured in terms of pixels, just like your screen coordinates. But your actual map location is going to be called LOC, so there'll be an old map location, and we'll want public access to current map location. Let's put these public ones up here together. And also you need to know the velocity of the character. Typically I make as many of my variables private as I can until I realize I'll need public access to it, and then I just change it to public after. In this case I know which ones are going to be public and which ones aren't. -14 is usually what I use for jump, and then gravity would be around 0.25. So it just keeps adding to that velocity. The velocity will start at -14 in the y direction, upward, and then it'll just keep adding 0.25 until it reaches a maximum downward gravity value, or until he collides with something. And we need to know his grounded status. So he does have these states here: start, air, and end for jumping, but he may not necessarily be in a jump animation. He might have walked off the edge of something and he's no longer on the ground, in which case he's not grounded. In which case you could do like a fall animation or the ending half of the jump, or just have him walk. It looks okay to do it that way. And when he gets hit, he'll become invincible. I didn't have to do this, but I reorganized these a bit just so it looks a little better, a little easier to read. I got the box up here now. As long as the invincible value is greater than 0, then he will remain invincible, and it'll just count down. So whenever you want him invincible, you can set that value to some higher number. And the initial damage, and I'm going to use integer for this, the initial damage of his first spell is going to be 1, so it's a very low level spell. This should be INP. Just going to quickly pause this and add some comments. I thought I'd just point out too that you're always going to need the old position and the current position for your world coordinate for your player or your monsters. So that way, if they're moving very quickly and you want to do a collision detection and a response, you can do what's called a sweeping test, or you can test the vector between the old location and the current location, find out the point of intersection, and offset the player so that it's just before that point of intersection. We're going to need access to MeoMotion and the Meow player. We'll call it Meow Hero. And this Meow player will actually be created in this class, so it actually belongs to this one. Whereas this one's going to be, the MeoMotion will be a reference, everyone will share it. And which direction he's facing graphically, so Boolean for flip. And whether or not we need to finish an animation before switching to a new one, because some animations must complete first, otherwise it doesn't look right. And an idle timer for when we're going to switch from the regular idle to the blinking idle. If you only have one idle, obviously that's not necessary. So we're going to keep an index for walk and ouch, and that way we don't have to look them up. Got some new comments in there. And we don't have spells yet, but we're going to add here a list of particle systems, and each particle system will be operating independently, so they'll all be generated when he's casting spells. So I'll just put list of spells, list of particle systems that make up spell castings. So for the spells, we're going to need a texture for those that holds the different images for the spells. Resolve. We're also going to need some explosion effects, so we'll add all that stuff later. First, we're just going to concentrate on having the controls and the character's collision detection and animations run correctly. Start with a constructor, and when we construct it, we can optionally set the starting world position for the character, and we'll take a reference to the quad batch object and a reference to the map so that we can share it, and a reference to our input system. And later on we'll want to add HUD stuff and explosions, systems, etc. Whatever else is needed for the construction of a player. So we'll set that starting world position. We'll hook up to our quad batch, so now we're referencing that. Same with the map, same with our tiles. Oops, this is lowercase. So this is the same type tiles, two-dimensional array. Since we have access to the map, we can just say bounce manager is equal to map.bounce manager. Input is input, and then later we'll do HUD, explode, etc. We'll go ahead and add our load, which loads the character's animations, taking a reference to MeoMotion, which we'll record here because we'll need it. And the texture map to use, we don't actually have that texture map yet, so we'll just go like this, and we're going to eventually need access to that explosion texture map, or texture map where spell images are kept. This isn't going to be used for explosions. That texture will actually be kept in the particle effects system. This is going to be for our spells here. So we'll have the spells on the same sheet, tiles images for whatever texture holds the spells. We'll record that rescale value as game 1, rescale. Game 1 does not have rescale yet. We'll have to add that. Go into your game 1 class, and where it says camera or cam pose, we're going to make this section into everything relating to the player. So player, MeoMotion animation, which I guess relates to other characters or actors. And we're going to make this static so everyone has access to it. Global variable, rescale. And typically you want to avoid static as much as you can, but this will be okay. And I'll just make a comment on this. So I made this static so that any creatures that are spawned, or your characters or whatever, they'll all be rescaled based on whatever the current resolution is. And that way everyone has access to it and they can all be scaled together. Okay, we're going to have a player class, which we're working on right now, and need the MeoMotion class. So let's go down to initialize and init MeoMotion. Now equals new MeoMotion content and quad batch. So now it has access to quad batch. And later we're going to init explosions here. And then we can pass that into the player when we do our load. And in here, under load graphics, we'll load our heads-up display stuff. We'll load our explosions. And we'll create our monster and our player, or monsters. Create our player and monsters. Create player, create a monster system. Here we'll say player equals new player. Screen center is where we'll put the character initially. Even though it's the world coordinates, not really matter. It doesn't really matter where we put them to start with, because the map will override where the player starts anyway. So we'll give it access to the map, our input object, and whatever else we need later. So later we'll add heads-up display, explosions, and whatever else. So at the bottom of load content, after adding the border, just before we create the level, let us load and set up player animations. So float resize. So this is how you want them to be resized. And this guy works good at about 60% of his original size. So we'll say rescale is uniformly resized horizontally and vertically by 60%. And then we'll have the MeoMotion class adjust that scale based on the resolution relative to whatever resolution you have it set for, and I'm sending it a reference to rescale so that it can change it, and the desired screen width and height, that is for the target resolution. And now we can say player.load and give it access to MeoMotion, and the image that contains our spells. I put them on the same image that the tiles go on, so if you don't want to do that, then you pass in something else. We actually can pass that in, so let's change this. So we do actually have this texture, it's not separate. I'll just go like this, go back to game one. And the editor is also going to need the player. So I'll just put a note here. Needs access to player. So we'll have to change that soon. And then that way, the editor, when you go to place your player or your player starting position, it has direct access to it. Okay, save it for now. I just added a few comments here. I'll just mention that in your update, you have a play mode and editor mode. You may have a story sequence or animated story mode, but anything that you know is not dependent on those for your updates that can run in all three, for example, like your map animations could also run in story mode or in the editor. For example, if you have explosions in the story mode, update explosions. So anything that can run on all three would go here for your updates. If you come down to your game state and go into your play section, somewhere before your bounce manager update, you can put in a player update, and we need to add player update in here, player class. And right now it doesn't do anything. So any player related stuff or player related animation stuff we can put here. So player, and after the player moves, kind of like with the editor, we want the camera to follow what you're doing. So we're going to need to move the camera to catch up to where the player is. We'll do it in a way where we take the difference between the player's position and the camera's position. If we just added that, then it would simply move the camera toward the player instantaneously. We're going to have it gradually accelerate towards the player. Or I should say we'll have it ease in to where the player is. So it'll actually slow down as it centers on the player's character. So this is how you smooth pan the camera toward the player's world position. And that's a type of ease in. So for example, if the camera was 100 pixels away from the player, the first time it would add 10 pixels, because 10%, and then it would only be 90 pixels away from the player the next time around. A more obvious example is if I use, say, 50%, then it would be 100 pixels the first time, 50 the second time, 25 the third time, 12.5 the fourth time. You get the picture. But if you want it to ease in a little slower, it would be 0.1, so 10% each time. If the player updates, then you have to update the camera's position, which means you'll have to update the world view to camera. And we've already created this, and that will also provide a matching background position. So the background will be scrolled appropriately based on where the camera is in the world. In player update, it's really just getting the input of what the player would like to do and what animations should be set. So then we're updating our camera based on that. Next, we take care of the collision detections. And those are world coordinate based, so we'll call it world collisions. Let's just copy this out of here. It doesn't exist yet. Go into player, public, void, world collisions. Starting here, we're actually setting all the actual animations. So anything that needs to be set, so update bouncers, setting all animations, for the player, I have a .set animation method, which I haven't created yet, so you're probably wondering about that. The player.update takes care of the decisions of the user input and what type of animations it would like to use. .set animation decides what animations we indeed are going to use and actually gets them running. So there may be conditions in which the desired animations won't necessarily be the animations that we're going to use. And monster animations would go here too. So I'll just monster, I'll say AI and animations. They can all go here. We'll go back into the player class. We'll add set animation after world collisions. So public void set animation, and it can take game time. And like I said before, it's good to have that option if you want to do any kind of online game programming. It's best probably to go based off that game time. Otherwise, I actually recommend doing it the other way. So this will be optional. And here we're going to have a switch. If the animation has changed that it wants to play, and only if it's changed, it will set up that new animation and start playing it. And we'll come down here to draw in game 1. And we don't have monster drawing yet. We'll add player draw. We'll need a draw method in here too. In player, we're adding public void draw. Go back to game 1 again, see if we're missing anything. Okay, oh, this has to go after the background, so we'll cut that from there. We'll just paste it after draw crystals. However, later we're going to want to take this and draw it onto a render target up here. And the reason for that is we're going to need any of the sprites that we want to reflect off of the crystals. Then we can just draw that render target in here after we're done, and it'll draw all the sprites to the screen in one shot. We can also use that render target then, with all the sprites on it, to render reflections onto the crystals. Okay, I just added some comments here. So back in player, let's load this player, and that's that wizzy.txt. It'll add the txt automatically. And we'll give it the rescale value that we calculated. So now that we've used the shared MeoMotion object to load an animation, we can go ahead and create a Meo player for this particular character. We're looking up the sheet name Wizzy because it was called wizzy.png. Since there's only one character on the sheet, that makes it fairly simple for us. So we'll pass in the necessary parameters. We'll have a section now for customizing those character properties, anything that we want to modify. First we'll just get an index for the animation we want to tweak, so index. And using the player's get index, we'll say duck. And for the ducking animation, we're going to speed it up because it's a long timeline and he's ducking down relatively slow. So we'll set the speed to 5 times faster. Let's just copy this line, paste it a couple times, and we'll do one for jump and for spell. You may want to play around with your animation speed values. Jump will run a bit slower at 70%, and that may speed up or slow down depending on which jump state he's in. For the spell, we'll say 2.5 times faster because he needs to complete that action fairly quickly. And I'm going to record the ouch index because it's one of those animations that must finish, because I want it to finish before the character does anything else as far as animation goes, so that the user knows for sure that the character got injured or damaged. But we may want the hero motion to change without actually changing the animation itself. So we'll keep track of both those states, and we'll check to see if the ouch index is on during certain scenarios. For example, if he lands on some spikes, it needs to jump off of them, but it's trying to finish the animation. You should be able to jump and be in the motion state for jump and transition into that jump as soon as the animation's finished. So we'll keep track of the ouch index for that. And if that didn't make much sense, it will make sense later because I'll show you what I'm doing. We're going to set its loop to be false just to make sure. Loop, and we know when it's done. And for this particular animation, I don't want to show the last key, so I'm just going to go num keys minus. And we'll get the index for walk because we're going to be modifying the properties of walk frequently. Control the walking speed based on the user input or analog control. And we'll set the initial Y offset up about 6 pixels. That way it'll line up better with the ground. And its initial speed will be 20%. So we'll set our starting animation for Meo Hero as idle. Idle 1.